All right, so here's our demo for the file system. We're just going to run through the demo in the background while we talk about the design choices and constraints about our file system. So I guess one of the biggest constraints that we have right now is that the file names are limited to 10 characters, which is kind of limiting. As you can see here, the file name too long.txt is not supported. So that's a pretty big limitation, Alexander.
Yeah, one kind of limitation that we have as well is just how extensive the functionality of a file system is, and sort of how many different scenarios you can concoct for writing and reading files of different length and all sorts of things like that, deleting files, making files. We implement a directory, a multi-level hierarchy for directories in the file system, which expands that complexity quite a bit. So it's a bit difficult to exhaustively test a file system, which was one thing that we found. Although we also found that we were pretty good at running into errors ourselves. Um, Something else as far as design decisions is concerned, the way that we keep track of free blocks is through bit vector map, which basically aligns or assigns a specific bit in the vector map to a specific block on the disk.
And that bit vector map is actually another one of the limitations of our file system. So the super block is the only block that contains that bit vector map. And so if you are to have a bit vector or want to have a file system that's bigger than the amount of bits that are free in the super block, that's just not going to be possible with this file system. So that's a pretty big limitation, and I think the maximum size there were like 250 some odd bytes free for the bit vector in the super block. So um, files can be like moderately sized, but definitely nothing like very large. So
Yeah, I think another limitation of our file system as well is the use of absolute paths for lookup or for like reading and writing, um, because you just have to traverse through, uh, the entire hierarchy of your file system. Another thing that is interesting is in order to traverse through um, sort of a file itself, through the blocks of a file. Um, I don't know if this is necessarily a limitation, but this is just how it works for our file system, is that you have to like read, you have to like read inodes, read data blocks to get to other data blocks, um, which sort of increases the latency for those operations. So that's something to consider as well.
yeah, especially if like each data block can translates to a track on a hard drive, then that means you're going to be doing a lot of seeking on your hard drive. So if you like try to read something in the middle of a file, you have to read through half of the file's inodes to be able to actually read that data in the middle of the file, which is very detrimental. So
Yeah, that's especially the case with our file system because obviously we do non-contiguous allocation. So whatever the next free block is in the system is a block that gets assigned to a file. So let's say you have a file that you create early on in your history, let's say, and then you do a bunch of other things to other files, and then you add more data to your first file. The likelihood that the two sort of data blocks associated with that file are close together uh, in like physical memory is very small. So that kind of goes back to what you were saying. If you were using a hard drive or something, the seek time for that would increase as well.
yeah. All right. Well, I hope you enjoy reading our code. Um, yeah, we'll have
We
more
sh-
of these details in writing in the README. So
yeah, and we'll also have directions for running through the demo file yourself.
yeah, awesome. Thank you.